do this first one because I think it's a good problem and has a lot of layers of complexity. So here we want to think about how certain solutions or certain ions are going to affect the solubility of lead carbonate. And so this reaction is going to take place. We're looking at lead carbonate forming lead ion and carbonate ion, and it has a KSP associated with it. So given the time, I'm just going to kind of work through a couple of these, and then I'm going to have you calculate the K. So if we add sodium carbonate to this solution, this adds CO3 2- to the solution, right? So just take a second here, and what will happen to the solubility of lead carbonate if we add more carbonate to the solution? Increase or decrease? So the solubility of lead carbonate will decrease. Alternatively, the amount of precipitate increases. So make sure you understand the difference in thinking about that. So amount of precipitate increases means it's less soluble. Everyone okay with that? Oh, and PPT is precipitate. All right. If we add HCl, effectively adding H+ ion. Did I not put these on, Carmen? I'm sorry. It probably would take me too long to do it at this point. Shit. I apologize. I'll post them filled in though. I will do that. So if we add H+ to this solution of lead carbonate, what do we know? What do we think could happen? Solubility increase or decrease? So solubility will increase because that H+ can react with CO3 2-, which is the conjugate base of HCO3-. So when that reaction takes place, when the H+ reacts with carbonate, it removes that carbonate from the equilibrium, increases the solubility. So the equilibrium shifts towards the products. That make sense? Okay. So those are tricky, and then we can make it even trickier by forming a complex ion. Okay. So let's say we add, and you wouldn't be able to, I wouldn't say you need to predict at all that these complex ions can form, but you should be able to recognize what to do with the problem if there is a complex ion. So if we add sodium hydroxide and that forms the complex ion lead hydroxide, it has a minus sign here. This has a equilibrium constant Kf of 3.8 times 10 to the 14. So it's very likely to form. Okay? So how does adding sodium hydroxide affect the solubility of lead carbonate? Increase, decrease, increase. Yep. So adding sodium hydroxide increases the solubility. Okay. Now we can calculate an equilibrium constant for the reaction of the lead carbonate solid with hydroxide to form the complex ion. Okay. And then here's some carbonate left over. So take a second and calculate that. You have our KSP and our KF here. Determine a K for this new equilibrium. Okay, so what this equation represents is our solubility equilibrium and the formation of the complex ion. So the first equilibrium here with the solubility has a KSP associated with it. The second one has the KF associated with it. When we add these two equations together, the lead ion cancels, and what we're left with ends up being this equation. Okay, I'm not going to rewrite it, but so then we can calculate a new equilibrium constant, K, and that's simply the KSP times the K sub F. And in doing so, our KSP is 7.4 times 10 to the minus 14. And KF is 3.8 times 10 to the 14. And so we'll end up with a new K of 28. Questions on that? Okay. All right. There was a problem in your homework that I think has the wrong answer in it. So I wanted to do one of these problems just to show you all how to do it and make sure we're on the same page. And if you put it in ChatGPT, it also, or actually if you put it in Google, it gives you the wrong answer as well. So I think it's just wrong. But this is I know this one is correct. We're going to do this one. We're going to calculate the molar solubility of barium fluoride, which has a KSP of 1.7 times 10 to the minus 6. But we're going to put it in a solution of 0.01 molar barium ion. Okay, so this is going to be your common ion problem. So our equilibrium for the solubility, barium fluoride, solid in equilibrium with barium 2 plus and 2 fluoride. So when we have a common ion problem, so this 0.01 molar barium is already in solution, that gives us an initial concentration in an ice table for the barium ion. So that initial concentration is going to be 0.01. We're going to have 0 moles per liter of the fluoride ion, and then the change is going to be plus X for the barium plus 2X for fluoride. And so at equilibrium, we're going to have 0.01 plus X barium ion and 2X fluoride ion. So when we plug this into our KSP, we're going to have 0.01 plus X times 2X squared. And because our KSP is small, we're going to ignore that X. Don't worry about checking assumptions with whether you can ignore X. Just ignore X today, tomorrow, whenever that might be. Okay? So now we have 1.7 times 10 to the minus 6 equals 0.01 times 2x squared. Divide both sides by 0.01. And we're going to have 1.7 times 10 to the minus 4 equals 4x squared. Oh, sorry, I put the x. I put the x, or the squared in the wrong spot. we go. And then when we solve for x, we're going to get 6.5 times 10 to the minus 3. So I think the problem on your homework did some funky math that ignored, I couldn't figure out what they were doing. I think it ignored the 2x or something. So make sure you include that, it's important. Questions on this? Yeah.
We always just make the assumption for this test.
Yes, for this exam, especially dealing with KSPs, just assume the x is going to be small. You can ignore it. Now, that's only when you're adding or subtracting it from another number. Okay. Other questions? Okay. What do we want to do? Okay. This is a fun one. This is a problem we got a question about earlier. So if you have a value of delta H and a value of delta S, calculate at what temperature the reaction becomes spontaneous. And note the wording, okay? At what temperature does it become spontaneous? It doesn't say above or below what temperature. I'm going to have you do that as the second step. So we went through in chapter 19 and determined that if the sign for delta H and delta S were both positive, then we couldn't, there was a temperature at which the reaction became spontaneous. If the signs are, one is negative and one is positive, then we can safely say it's spontaneous or non-spontaneous. But in this case, we have to figure out a temperature at which that changes. Okay. So I don't think you're going to get the equation that is, oh, I should have looked harder. T equals delta H over delta S. Do you get that or no? Do you remember? No. Okay, so be able to manipulate that one. This comes from delta G equals delta H minus T delta S. And that's setting delta G equal to 0. You know, I don't think I actually did the math, so I might need some help here. Also, another easy place to make a mistake are the units. Okay, so we have kilojoules per mole for our delta H in joules per mole Kelvin for the entropy. Make sure you convert that either both to kilojoules or both to joules. So I'll do kilojoules. So I have 133.3 kilojoules per mole. And then our delta S is 0.1216 kilojoules per mole Kelvin. Okay. What do we get? I didn't actually do this one. Anyone do it?
I got like about 1,096 Kelvin.
1,096 K. Cool. So is it above this temperature that is spontaneous or below this temperature that is spontaneous? It's above, yes. And spontaneous above 1096 Kelvin. So this goes back to that table that we were referring to. If you have a positive delta H and a positive delta S, only above a certain temperature does that reaction become spontaneous. Below this temperature, it's going to be non-spontaneous. Okay? There's probably a bit of memorization to do with that table. Make sense? let's do. Okay, so this is one that I sort of stole from the practice exam. It's like changed up just a little bit because I didn't like the one on the practice exam. So it asks, which of the following reagents will spontaneously oxidize nickel solid to nickel 2+? And so I'm giving you just there's a whole table of standard reduction potentials, but you essentially have two options, either the zinc 2+ ion or the iron 3+ ion. Make that slightly bigger. So I'll let you think just a little bit how you would solve that one. Okay. So when I first looked at this problem, I think I tried to overcomplicate it, which is, if you're doing that right now, we're on the same page, right? This is essentially an E-cell calculation reaction. And when I thought about that, it made it a lot easier for me. Okay? Because the question wants to know which reagent is going to spontaneously oxidize nickel. So that gives us two pieces of information. We know it has to be a spontaneous reaction, which are essentially a galvanic cell, which means that the cell potential must be positive. Okay? And we're going to oxidize nickel. So nickel has to be at the anode. Okay? So if we look at the nickel reduction potential, and remember in this equation, E cell equals E reduction at the cathode minus E reduction at the anode. We only use reduction potentials that are given in the table. We don't need to do any funny business adjusting those values or anything. So our nickel reduction potential is minus 0.28. So we can go ahead and put that right in the equation. And these are in volts. I'll just put my V over here. Okay. We know the E cell has to be positive. And we would most likely give you, we will most likely give you an answer that will work and an answer that won't work. Okay? Sometimes they both work. But we need to have that positive cell potential, okay? So we can essentially try these out. So if we have the zinc 2+, that has a reduction potential of 0.76. And if we have minus 0.76 plus 0.28, we're going to get negative 0.48 volts, a negative cell potential, and so that will not spontaneously oxidize nickel. Okay. The other option was the zinc 3+. And that was here as a positive 0.77 cell potential, or reduction potential. Okay, and if we put that in our equation, 0.77 minus negative 0.28, we end up with 1.05 volts as our cell potential, which is positive, which means it will occur spontaneously. And so that says that the iron 3+ will work in this case. Okay. Yes?
How much better nickel was the
I knew that the nickel was the anode because in the problem it said we wanted to oxidize it. So oxidation occurs at the anode every time. Yeah.
On the practice test, I remember this problem, it was like zinc ion, and it was like iron solid.
Yeah.
How does that change?
Yeah. Did you listen to the full video? I'm not offended if you didn't.
I don't remember. I think I did, but I don't remember what it said.
Okay, so the options, and this is why I didn't like the problem, because the options on the one on Carmen, I think we were going to oxidize zinc, and we were given the option to use iron solid. Okay, and that won't work, and the reason being is that you cannot reduce iron solid. So you can't form an anion with iron. And that was like the reasoning, which I don't love that answer. I don't love that question because I think you all have good chemical intuition, but that to recognize that you wouldn't be able to form an anion may not be intuitive. So that is the reasoning behind that, is you can't form iron -1 or -2 or whatever it might be. And so it will not oxidize, or it won't reduce iron. Yeah, reduce iron. So yeah, that was the reasoning behind that one. Like I said, didn't love it.
Is that the same for other metals?
Yeah. So if you have a solid, any of these solids, heavy metals, the iron, zinc, nickel, copper, they're not going to form, silver won't form a negative ion. Sodium won't, lithium won't. So yeah, it's kind of it was a silly question. Yes?
If it's not spontaneous, does that just mean it's going to be negative?
Yeah, if it's non-spontaneous, it'll be negative. The E cell will be negative. Yeah. I have a couple more problems. Would you like me to pick one more? Are you good? Or you want to ask me more questions? What are y'all feeling? How are you doing? Yep. What type of problem will be the most complicated? I don't know. I feel like I picked some of them to do examples of, which is, kind of what I tried to do with these. I don't know. What do you think is the most complicated?
Like, I just haven't seen many, like, fill in the blank ones on the practice exams, so, like, I'm assuming most of them are going to be multiple choice, which is, like, helpful, at least for, like, guessing and checking.
Yeah. With the chapter 19 stuff, there's more likely going to be fill in the blank or like conceptual questions there, because there's not a ton of stuff that we did that was, a calculated thing. So yeah, chapter 19, look at that for conceptual. I mean, it's open for all of it, but yeah. You do not need to memorize solubility values. So yeah, you'll be given KST. Or like the solubility table, all chlorides are soluble. Be familiar with that. So, but I think that things will be clear where that isn't as important as it was last time. All right, good luck, everyone. Yeah, not the best time. I know there's sections, yeah. If you have questions, let me know. Like, for the yeah, I'll try to do that. I have like a long day after this, but so it might not be till later tonight. Yep.
So I was interested in a history minor actually, but before I decided that, and before I decided to take English, so I was wondering if I could come to your office hours on like Thursdays to come and talk about that, like what that those kind of things look like. Sure. And also, did the squirrel move into the house yet?
I don't know. I'm giving him some time.
Oh, okay.
I am going to check.
I was wondering if electrolytic cells run. There's actual
There were no, just uptake organic cells, self-protection cells. No, nothing where it's not contaminated.
I just had a question about that homework, the one from the homework you went over. Like, I just could not figure out the right answer. I just put points on that. Like, I just respected it. Is there any way to just use for that question? The 20.4, the BASP solid. I just.
Oh, wait.
Yeah, and when I requested it, I'm sure it didn't even have it. It said like instructor will help. Usually I request it. Yes, I will. Thank you. Yeah.
I do mine differently. Okay. But it's the same. And maybe, I think it's the because what I do. We're trying to yeah.
during my exam yesterday, I accidentally submitted the quiz before I could finish. And I emailed like the Gen Chem, but they still haven't got
Gen
got
Chem
back.
exams?
Yeah, Gen Chem exams.
Okay. Those are the right people. Can you send me a Carmen message to talk with Dr. Turner? Because I think he's the one who looks through all this.
Okay.
So just send me a message and say, hey, we talked to the class about things. And I'll make sure that, because I believe they're going to take it and forward it to him. Okay. So I'll just try to get to that. I'll take a look at it and we can hopefully come up with something. All right? Cool. Hey, what's up?
Afternoon, Dr. Foods.
Yeah, what's up?
I talked to you yesterday. My name is Drew. I talked to you yesterday over email.
Okay.
It didn't show the submit button, and it just told me to keep going after question 20.
Okay.
So I sent, my TA told me to send an email to a lab supervisor, and I sent that to you.
Right.
And then you told me to send it.
Yeah.
I sent them 2 emails, but they still haven't gotten back to me. I told them like I told you.
So one of your classmates said the same thing, like they had an issue. I imagine they're getting a lot of emails right now, so they might not be able to get back on you right away. Remind me again which that was?
Yeah, so what happened to me was I got to question 20.
Okay.
And instead of saying submit, it said finished. So automatically I assumed that, there was more questions I took, but it submitted my exam. So like,
So I think there's 20 questions, but you were going to go back and work
oh
through some things?
yeah.
Okay.
But it never said that was the last question. If you want to
Yeah, I don't remember electronic engineering. I haven't taught them 12 pen in 10 years, and I